So in the last class, we had seen about the graphics libraries, the primitives that are being used. So now today we'll see about the 2D transformations, two-dimensional transformations. Uh, so that is nothing but what are the changes that we generally do on a system, uh, either in two-dimensional form. So it can be transformations of an object from place to place or rotating it, revolving it, right? So there are basic transformations that is required. So since it is only 2D transformations, generally two axes are considered. Only two axes should be there. So let us take only the x-axis and the y-axis. So the basic transformations, that is the changes that we are going to do in general, right? Irrespective of whatever the software, the CAD, CAM, or CAE software that is going to be used. Okay. So in that, the basic changes that we generally do are nothing but the translation, rotation, and scaling. Okay, these are the basic transformations that we generally do. So what is this translation? Translation is nothing but we want to say, for example, we want to move an object from one coordinate to another coordinate. So we want to replace that. I do say, for example, if I take up this point P, okay, so I want this not to be here anymore. I need to be at this particular new coordinate over here, not at this place. I want to move to this particular place. Okay, it can be move command, it can be shift, it can be copy command. Okay, or I'm just going to delete this. I placed it in the wrong place. No, I just want to push it from here to here. It can be anything of this, right? Or even I want a same type of this to be here also, or parallel to this in the y-axis, or parallel below, or parallel towards the right side. So irrespective of the command, that the type of command that we use in the CAD software, okay, it is nothing but we are going to move it from one place to another place. So that is from one coordinate to another coordinate. So let us take up this example. We have the x and y axis. Okay, we have the x and y axis. So let us have a point over here. I'll let it call it as P, which is having a coordinate of x comma y. So I want to this point to be moved to this new place P dash, whose coordinate will be x dash comma y dash. Okay. Now, for this to be moved, I should know by how much should I move it in x direction and how much should it be moved in y direction. So how much should it be moved in x direction? I'll call it as tx, that is, since it is translation, okay, translation in x direction tx, translation in y direction ty. Okay, so how much distance should we move it in x and y direction? So to have this thing for an object or a point or anything, okay, to be moved from its initial point to a final place, okay, we should know three data. We should have three data. Out of these three data, we should at least have two, so that the third one can be found out. What are these three data? One is the initial coordinate. What is the coordinate of the object at the initial position, p, x, comma, y? Second thing is, what is the coordinate at its final position? P dash is the new position, okay, having a coordinate x dash comma y dash. The third one is that by how much should it be moved, that is tx and ty value. What is the incremental value that we should give? What is this? By how much should we move? So out of these three, any two should be known so that the third one can be found out. Okay. So let us see this. How does the computer understand, or what data has to be given? So initially we have the point p x comma y, final point p x dash comma y dash. Okay, so let us now take up. So if I want to have this from the initial position, okay, so let us first only transfer this point in x direction. Okay, so it has to, from x value, the point should move to an x dash value. Okay, right, so that is the new 1. So x dash is going to be what? X dash is going to be x coordinate value plus by how much should it be moving? Tx, translation in x direction. So plus Tx will give the new coordinate value as x dash. So similarly, since there is a change even in the y direction also for this final point, so how do we get the y value coordinate? Y dash is equal to the initial y value plus the translation in y direction. By how much should it be moving in y direction is the ty value. So adding this initial value plus translation in y direction will give the new y coordinate value. So if we write the same thing in matrix form, so x dash y dash is the final value. So how do we get this? We get this by the initial value, that is the initial coordinates x and y, plus the translation values in x direction and y direction. How much should this point move in x direction? How much should this point or object move in y direction? That is going to be the tx and ty value, where the summation of these two matrices will give the final coordinate values. So in general form for this, how they'll write is p dash is equal to p, that is the initial coordinate values, plus the translation values, that is tx and ty value. Okay, so this is how it is being done for any object or a point or anything in CAD, CAM or CAE systems, where it has to be moved or switched over from one coordinate to another new coordinate value. Okay, right. So the next thing is that we'll take up an example of, uh, let us have a polygon and let us see a simple calculation. How does it work? So over here for a polygon, let me take, there are only three corners. So A corner having 2 comma 5, B having a value of 7 comma 10, C having a value of 10 comma 2. So let us take the translation value for all these coordinates. So it has to move in x and y direction by a value of 2. Okay, so let us consider point by point. So for the corner A, okay, point A, the new value after translation will be, okay, so the new value A x dash comma y dash in matrix is equal to the initial value of the point coordinates of A plus the translation value, that is initial value is 2 comma 5 and the translation values is 2 and 2 in x and y direction. So add this, when we add this, x plus tx value 2 plus 2 4 and 5 plus 2 7. So the new coordinate after translation for A point will be 4 and 4 comma 7. Okay, so similarly for point B, if we take a look at it, so it is initial value 7 and 10. Okay, so the 7 and 10 is the initial value, translation values are 2 and 2. So now when we add 7 plus 2 will be 9, so 10 plus 2 12. So the new value after translation for point B will be 9 comma 12. And similarly it is the same case how it is being done for point C. So how many more corners are there or points are there in the object? When we go into move, this is what is going to happen inside the system. So this is how it is going to calculate. Okay, so the next thing is, we'll go on to the uh, next transformation, that is the rotation. That is the rotation. So we have generally seen, we want to rotate an object in solid edge or any kind of um, CAD or CAE systems softwares, that is, it can be solid edge or ANSYS, Abacus, SolidWorks, whatever. So the generally this rotation transformation will be used when we use the options called rotate. Okay, so there we are going to rotate the object. So that means we are going to shift the object from one coordinate to another new coordinate value, but by rotation, having a common center of rotation point. So that means the radius from the center will be the same at the beginning and at the end after that is after rotation also. Okay, right? So this is what is going to be in rotation. So for this rotation, let us have the initial value. We have a point over here p x comma y, okay, at an angle of alpha, an angle alpha, right? Okay, right? So at an angle alpha, but whose height is now at a distance of y, and in the x direction will be x. So that is what we have, x comma y, right? So now it has to be rotated by this, from the center of rotation, okay, by an angle of theta. We wanted to rotate it by an angle of theta, so that the new value will be x dash comma y dash. So if we know what is the angle, then we can find out what is the new coordinate after rotation. But we should know what should be the angle of rotation for this. Now at the final position after rotation, the new value for this p dash point coordinates will be y dash is the height at which it is being placed, and the distance is now x dash. Okay, but the radius is still the same, no change. Okay, right? So let us see that. Now first let us see how to find out the values of x comma y, that is the initial value. So to find the value of x and y by using angles, how can we do? Now if we take up this is a almost a right angle triangle. Okay, so cos alpha is given by adjacent side by the hypotenuse. Adjacent side value is x, hypotenuse value is r, so x by r. Okay, so if we rewrite this, I want to find out now what is the x value. So if I rewrite this equation, okay, x becomes r times cos alpha, right? R times cos alpha. So similarly, I want to have the value of y. Okay, so if I need that, sine alpha, which is nothing but opposite side by hypotenuse. So opposite side is at a height of y, and the hypotenuse value is r. Okay, so y by r. So if I want to find out what is the value of y, then we need y is equal to r times sine alpha, right? So if we know the angle of alpha, then also we can find out by this. We should know what is the x, we should know what is the value of alpha r. So then we can find out x and y, that is the initial point. Okay, right. Now let us go to find out what is the, after rotation, what is the value of x dash and y dash after rotating by an angle of theta, right? So in that case, what happens? Let us see. So to find out this new values of x and y, okay. So what is this cos theta plus alpha? Let's find out what is the x dash value first as it is. So now this cos theta plus alpha, because this point is here starting from the x axis. So it becomes, already it is by an angle of alpha, plus if it has to reach till here, all the angle measurements are always taken from the x-axis, so it becomes theta plus alpha both put together. So that is why we have cos theta plus alpha, whose values are nothing but the x dash by r, because the radius is same, no change in the radius as it is rotation. So now if we want to find out the new value, that is the x dash value, x dash is going to become r times cos theta plus alpha. Now if we rewrite this cos theta plus alpha, we have this formula. So it becomes cos theta plus into cos alpha minus sin theta sin alpha. Already there is multiplied by r, so we'll write that r also, right? Now if we expand this, it becomes r cos theta into cos alpha minus r sin theta into sin alpha. But if we have to if we are going to simplify it, r cos alpha, we already know here it is nothing but it stands for the value of x. So we can rewrite this r cos alpha as x, and the remaining is cos theta. Then the next thing is r sin theta sin alpha. So r sin alpha we have here, which will be denoted by y. So we can rewrite these two terms combinedly, since it is multiplication by y. The left out term is sin theta. So ultimately, to find out the new value of x coordinate, okay, will be x times cos theta minus y times sin theta, right? So similarly, let us see for doing it to find out the y value. Okay, so here it happens to be, what is that? Here it is going to be sine theta plus alpha, because we want to find out the what is the change in the y axis or the y coordinate. So y dash by r. Okay, so it is going to be y dash by r, sorry, it is y dash by r. So y dash by y dash is equal to r times sine theta plus sine alpha. So once we rewrite this, it's going to be sine theta plus alpha can be written as cos theta sine alpha, right? And plus cos alpha sine theta. So once when it's already being multiplied by radius r. So once when we expand, remove the brackets, it's going to be r cos theta sine alpha plus r cos alpha sine theta. But we already know that r sine alpha is going to be the y value. So it is going to be y times cos theta plus r cos alpha is nothing but x value. So it is going to be plus x times sine theta. So ultimately for y dash value, it is going to be y cos theta plus x times sine theta. Okay. So this is the equation for rotation. And now if you want to write the same thing in matrix form, to put it in simpler form, okay. So in matrix form, we can rewrite this as, so x dash y dash will be equal to x comma y, sorry, xy in matrix, and it is going to be cos theta minus sin theta, because it is going to be multiplied. So x times cos theta plus, sorry, minus y times sin theta, right? So if we look here, what is the uh, value of x dash? X times cos theta minus y times sin theta. So x and y in one matrix, cos theta and sin minus sin theta will be left over, which will be put into the other multiplication matrix. So since it has to be multiplied here, okay, so here we are going to have x times cos theta minus y times sin theta. And similarly for y dash value, it is going to be what? It is y times cos theta, right? Okay, and uh, x times sin theta, right? So x times sin theta into y times cos theta, which we get back this same equation. So in the matrix form, it is going to be written like this. So in simpler form, if you want to write for rotation, we can write it like this, where P dash will be equal to P into the value of the rotation matrix, that is cos theta sin theta minus sin theta cos theta will be the rotation matrix. Right. So yes, so we'll take up one example to just one simple example. So we have initially a point whose coordinate is 4, 3, and the angle by which it has to be rotated is going to be 45 degrees. That is nothing but the theta value is 45 degrees. So in that case, let us solve this for these values by the given equation. Okay, so x dash value, we have the equation x times cos theta minus y times sin theta. Okay, so x value is 4, cos theta value, cos theta is 45, cos 45, minus y value is 3, sin theta sin 45. So now if we rewrite this, it is going to be cos 45 is nothing but 1 by root 2, sin 45 is also 1 by root 2. So 4 into 1 by root 2 is going to be 4 by root 2 minus 3 into 1 by root 2 is going to be 3 by 1, sorry, 3 by root 2. So ultimately simplifying this, we will have 1 by root 2 will be the new value of x after rotating by an angle of 45 degrees. So similarly, when we solve for the y value, initial value is 3. So sorry, y dash is going to be y cos theta plus x times sin theta. So y value is 3, cos theta cos 45 plus x value is 4, sin theta, that is sin 45. Okay, so here it is going to be 3 by root 2 plus 4 by root 2. So ultimately simplifying, adding it, it's going to be 7 by root 2. So the new value will be at after rotation by 45 degrees, its new value will be 1 by root 2 and 7 by root 2 is the new value. Okay, right. So this is how the uh, the rotations are being done. Okay, right. So the next thing we'll see about is about the scaling. The next type of transformation is about scaling. So for scaling, what is this scaling? Now if we take up this example of scaling, if I have a triangle, okay, and I want to scale it, I want to scale it to bigger size. So it has 3 points. Okay, it has 3 points. So for each of this point, okay, there is going to be a change in its x value, y value. Okay, since it's only a two-dimensional figure, so there's going to be a change in this point number 1, 2, and 3. So new values will be 1 dash, 2 dash, and 3 dash. So for each one of this corners 1, 2, and 3, it has got a new x value and y value, since we are going to scale it. Either we are going to scale it or we are going to make it of a much more smaller size. Anything of this, either from here to here decrease the size or increase the size. It can be either. So scaling is nothing but a kind of, where do we use this, is nothing but even in zoom also. So we do zoom out, zoom in and zoom out. So that is nothing but using the window option. So there also the scaling only comes into picture, because it has to appear onto the screen as a much more bigger figure, okay, for the selected portion. Or else we are going to select the entire diagram, and there is one option in CAD softwares which is called as the scaling option, where we enlarge or diminish the size of the object or the drawing. So for this, we should have a scaling value. By how much should it change? Each one of these points or coordinates, by how much should it change? So we represent it by Sx value for the change in x direction, and Sy value for the change in y direction. By how many times it has to increase? So it has to be basically multiplied. Okay, so let the initial point value, let us take only one single point whose coordinate is x comma y. Okay, and its final point value, by how much it has to be scaled, is nothing but x dash and y dash value. So let us assume a uniform scaling value of x and y to be for amount of 2. Okay, by an amount of 2 for x, and sy will also let it be scaling factor, let it be 2 only. So x value, when you are going to change, so x dash is going to be what? The new value after scaling, x dash is going to be x into the scaling factor. Okay, that is Sx value. And similarly the y coordinate, y times y into the scaling factor in y direction. So what happens, there are two things that we have to take care of here. So we have seen here, either it can be enlarged or it can be diminished, that is making it a smaller size. How does it happen? So if Sx and Sy values are greater than 1, because this size is considered to be as 1, that is the ratio is 1, that is 100%. Okay, so if it is greater than 1, if I give 1.5 times or twice, so that means it is going to multiply by 2 times the size of this, right? So that means during that time, it is going to, since we are going to multiply over here into 1, there is no change in the size of the object. But if I make it 2 times, that means 2 into whatever is this value. Say if I have 3, so 3 into 2, I'll have 6. Okay, twice it has changed. Initially it was 3, final value is 6. So it has been changed by a scaling factor of 2 times. Okay, so it is going to be double the size. So it is, since the value, the scaling factor 2 is greater than 1, the size of the object or for that coordinate is going to be twice. It is going to increase. So if the same thing is going to be by less than 1 value, the size will decrease as shown over here. Okay, so generally we give in the scaling factor, even in solid edge also, we give the scale as saying that, okay, 1.5 times. Sometimes we want to reduce it 0.81 times, which we generally do in isometric drawing, 0.816. So that is nothing but scaling only. So 0.816, right? So it is less than 1. So the value of each one of those lines in the diagram will be multiplied by 0.816 for isometric drawing, right? So that is one thing that we have, one variety. The other condition is that if the scaling factor Sx and Sy values are same, then it is either called as uniform scaling or homogeneous scaling. That means every point, every coordinate is being scaled to the same change. It is going to be either multiplied by 2, 2.5, or reduced by 0.5, zero point 0.8, and so on things. So there will be a uniform increase in its size in all directions, or there will be a uniform decrease in the size in all directions. But in case if we need, there is another option or a condition where the Sx value and Sy value, that is the scaling values in x and y, will not be the same. So then it is called as non-uniform or heterogeneous scaling, right? So generally, as I told you, in solid edge we use the option scale. Okay, so there it will ask you by how many times mention the scaling factor. So we will give 0.816 for isometric drawing. Okay, 0.816. So what has happening? This, if you have a triangle, it is going to be of a smaller size after scaling it down, right? So that time, what is that? 0.816 is the same value for x and sy. So it is going to be a uniform scaling, right? It's going to be a uniform scaling, right? So this is all about the scaling. So here we are cover up the basic 2D transformations. We'll continue the remaining topics in the next class.